In this video, we'll introduce MATLAB Classification Learner app and Regression Learner app. What we'll be doing in this video and the following videos is to explore how these apps can be used to quickly train models. We'll also evaluate their performance, deploy them in the MATLAB workspace, and generate code from it for further use. Specifically, we will begin by discussing the difference between classification and regression problems, and we'll have a quick look of the dry bin dataset and demonstrate how to load it into MATLAB. In the next video, we'll start using Classification Learner app to train a series of models to tackle a classification problem using the dry bin dataset. Then we'll learn to export the model from the Classification Learner app into the MATLAB workspace to do some further testing. And finally, we will apply the same process using the Regression Learner app. The key difference between classification models and regression models lies in the type of output they produce. In classification problems, we define which category or class an input belongs to based on the features provided. For example, a classification model might predict whether an email is spam or not spam. On the other hand, regression models predict continuous values rather than categorical ones. In a regression problem, the goal is to estimate a continuous output, such as predicting house prices based on various features. Unlike classification, where the output is a single category, regression can involve using a set of input features to predict multiple continuous values. Here is a brief overview of the process we'll be following with the Classification and Regression Learner apps. So we will start with some training data, which we'll use to train our model. This involves feeding the model input features along with the corresponding labels for classification or continuous values for regression. After training, we will test the model using a separate set of test data. The model will make predictions based on this test data and will compare the predicted labels or values with the actual ones to assess the model's accuracy. And finally, once we have the tested and validated model, we can use it to make predictions on new unlabeled data. This step is where the model is applied in real-world scenarios to predict outcomes based on the features provided. So this pipeline, training, testing, and predicting, is what we'll be following as we walk through the apps. Alright, before we jump into using the Classification Learner app, let's first take a look at the dry bin dataset. I've already extracted the dataset file into my working directory. I'm going to open the text file here, which gives us a brief overview of what the dataset is all about. The dry bin dataset is indeed quite popular. It includes 13,611 labeled data points with 16 features. These features are split into two categories. 12 are dimensional related and 4 are related to shape. These features help us identify which type of bin each data point represents. There is more detailed information available about the features, which you can check out if you're interested, but we'll move on for now. Now let's talk about how we're going to prepare the data. We'll start by loading the data into MATLAB using the read table function. Then we split the data into training and test set using the CV partition function, with 10% of the dataset set aside for testing. This function gives us a logical array for the training data and will generate a similar array for the testing data. So if we run the section, we will have the whole dataset loaded, along with our training and testing datasets. So now let's take a quick look at our training dataset. You will see that it contains 17 columns. 16 of these are features, and the last one is a label for each data point. If we scroll down, you can see the different values of the features and different classes represented by the labels. So going back to the line script, we want to check the class balance of our dataset. To do this, we can count the unique entries in the class column to see how many classes there are. We can use MATLAB's group counts function to calculate the percentage of each class in both the training and testing datasets. Then we will combine these percentages into an array and plot them. So we run the section. We have the plot here. In the x-axis, we have bin classes, and in the y-axis, we have percentage. The blue bars indicate the percentages as a whole. The red line is the training dataset, and the yellow is the test dataset. From the plot, it's clear there is an imbalance between the bin classes, and we also have the imbalance between training dataset and test dataset. As you can see, the dermation data in the training dataset is less represented compared to the test dataset. Now that our data is ready, with our data now prepared, we are all set to start using the Classification Learner app. Thanks for watching. I will see you in the next video.